In this math tutorial, you will learn 1. What is proportion? 2. What is the difference between proportion and ratio? 3. What is the difference between proportion and rate? 4. What are the names of the outer and inner terms of a proportion? 5. How many types of proportion are there? What is the difference between them? 6. How do you express a direct proportion graphically? 7. How do you express an inverse, indirect, proportion graphically? 8. What is the graph shape for direct/indirect proportion? Why? Introduction. You are traveling by car at low speed but you notice that you are late. What do? How does the increase of speed affect the distance traveled? What about the time elapsed? How does the increase in speed affect the traveling time? Suppose you have to complete a job alone in 5 days but you are not able to do so. What do in this case? Can you complete the task within this deadline if friends come and help you? How does the number of people affect the time to complete the task? How does the number of people affect the amount of work done? In this tutorial we discuss proportion and its types. This is because proportion is a very important concept that shows how two quantities are related to each other. Proportions are very common in daily real-life situations. Definition of proportion. If two quantities involved in a situation, we call them variables, are related in such a way that if one quantity changes, the other quantity changes at the same, or opposite, degree, we say that these quantities are in proportion with, or proportional to, each other. In simpler words, a proportion indicates to us how one thing changes in relation to another. For example, if a car travels 240 kilometers with 8 liters of gasoline, it can travel for other 720 kilometers with 24 liters of gasoline if moving at the same rate, speed. The unit rate, UR, of gasoline consumption therefore is as shown on screen. Since their two unit rates are equal, we say they are in proportion. Hence, it is clear that a proportion includes two equal fractions, i.e. then A and C are proportional, as well as B and D. In other words, if A over B and C over D are two equal ratios or rates, they are in proportion. We can also write the previous proportion in the form as shown on screen, where A is the first term, B is the second term, C is the third term and D is the fourth term of the proportion. The terms A and D are called outer terms or extremes, while B and C are called inner terms or means of the proportion. Example 1. Which of the following pairs of fractions shown on screen are in proportion? Solution 1. First, we express each fraction in the simplest terms. In a certain sense, a fraction expressed in the simplest terms is similar to the unit rate, in fact, one of the two associated unit rates, we discussed earlier. Thus, A. Since these two fractions are not equal, the quantities they represent are not in proportion. B. These fractions are equal, so the quantities they represent are in proportion. C. Since these two fractions are not equal, the quantities they represent are not in proportion. Direct proportion. There are two main types of proportion, direct and inverse proportion. In direct proportion, the quantities A and C change in the same way as well as B and D. In the example given earlier, the number of kilometers traveled is proportional to the amount of gasoline consumption. From the numbers, it is clear that if the number of kilometers triples, the gasoline consumption triples too. This type of proportion is known as direct proportion. By definition, direct proportion is the relation between quantities whose ratio, or rate, is constant. We will see later that two quantities that are in inverse proportion behave in the opposite way, i.e. when one increases, the other decreases. In the example with fuel consumption, this constant was the unit rate of gas consumption expressed in km/L. In both cases this number was 30 km/L. Let's see another example involving quantities that are in direct proportion with each other.
Example 2.
5 workers can carry a 200 kg load from the point A to the point B. How many workers are needed to carry 760 kg load in the same route? Solution 2. This is a direct proportion example where any increase by a certain factor of the load brings the necessity to increase the number of workers by the same factor. Hence, we can use two approaches to find the missing quantity. 1. To find the unit rate first, which in this specific example corresponds to the amount of load a single worker can carry, and then divide the total load to this number in order to find the number of workers needed. 2. To write the proportion in the form, A/B equals C/D, where D is the missing quantity. Thus, using the first method, we have load carried by a single worker equals reference load over reference number of workers. Thus, we have the following as shown on screen. Since the actual load to be carried is 760 kg, we obtained for the number of workers needed for this work the following as shown on screen. The second method is shorter. We write the following as shown on screen. As you see, the result obtained is the same with either method used. Graph of direct proportion. In Ratio Tutorial 4.1, we prove that ratios produce a linear graph. Since the direct proportion is obtained by two equal ratios, it is easy to conclude that the graph representing a direct proportion is a straight, sloped line that starts from the origin. Otherwise it is not a direct proportion, where the slope is determined by the simplest form of the ratio or of the unit rate. Let's consider one such a graph to clarify this point. The graph on screen is not an example of direct proportion because the ratios of position at the two given instants are not the same as the ratios of time. In other words, 320/110 is different from 20/10. As the first ratio gives 1.5 and the second gives 2. Therefore, the quantities involved in the previous situation are not directly proportional. In simpler words, the graph must start from the origin in order to have a direct proportion, as shown on screen. Here, both ratios are the same as 220/110 equals 20/10 equals 2. Therefore, the quantities involved are directly proportional, or simply, proportional. It is better to solve the situations with ratios, not with rates when dealing with proportions. In other words, it is better to divide two like quantities instead of the unlike ones. Example 3. Which of the following situations involves a direct proportion? A. A car can travel 200 km with 12 liters of fuel and another 300 km with 20 liters of fuel. B. 5 kg of paint can paint a 30 meters squared wall while 12 kg of paint can paint a 72 meters squared wall. Solution 3. A. We will check whether the ratios are equal by dividing the like quantities. We have the following equation as shown on screen. The first fraction gives 2/3 while the second gives 3/5. Therefore, this situation does not involve a direct proportion. B. Again, we take the ratios. We have the following equation as shown on screen. The first ratio is already in the simplest form, and the second ratio gives 5/12 when written in the simplest terms. Therefore, the quantities involved are proportional. Cross-product indirect proportion. As we explained earlier, a proportion is written in the form as shown on screen. This is the ratio form of expressing a proportion, where all units are simplified. However, another form of writing a proportion is by expressing it as a rate, i.e. as two fractions where the numerator and denominator of each represent two different quantities. The units cannot be simplified. For example, if 16 tailors can make 40 shirts in one day, then obviously if the number of tailors doubles, 16 times 2 equals 32, the number of shirts they can produce doubles too, 40 times 2 equals 80. Therefore, if we use the previous notation, we have the following as shown on screen. Hence, the two methods of expressing this proportion is as shown on screen. From the two previous methods of expressing a proportion, we know that A and B can switch their position as well as C and D, and still the proportion is valid. From Chapter 1, we know that the only two operations that possess the commutative property are addition and multiplication. Since ratios are expressed as divisions, which are multiplications by the inverse, we can write the ratio as two products on either side of the expression. Hence, we can write a direct proportion as shown on screen. This method of expressing a proportion as equality of products is known as cross product. Considering the numbers written in the previous example, we can write the following as shown on screen. The result in either side is 1280, which confirms the proportion. The cross-product method of writing a proportion allows us to check the veracity of proportion in an easier way without involving rational numbers, simplifications or GCF calculations. Example 4. Check the veracity of the following proportions by using cross products. A. 3 to 12 equals 7 to 21. B. 20 to 15 equals 36 to 27. Solution 4. A. First, we write the possible proportion in fractional form. We have the following as shown on screen. Now, we can write the proportion as cross product. Since the last equality is not true, it is clear that the original proportion is not true either. B. Again, we write the possible proportion in the fractional form. We have the following as shown on screen. Now we write the expression as a cross product yields as shown on screen. Therefore, the original proportion is true. Inverse, indirect, proportion. This type of proportion occurs when the quantities involved change inversely, i.e., when one of them increases by a certain factor, the other quantity decreases by the same factor. For example, if 20 people can do a job in 5 days, it takes 50 days for 2 workers to complete the same job. This is because decreasing the number of workers increases by the same factor the time necessary to complete the work. By definition, inverse, or indirect, proportion occurs when a decrease in one quantity or variable causes an increase by the same factor in another quantity or variable. If we continue operating with the symbols of direct proportion, we can express an inverse proportion as shown on screen. Example 5. A car traveling at 60 km per hour reaches the destination in 3 hours. How long does it take to this same car to reach the same destination if it travels at 20 km per hour? Solution 5. From physics, It is known that distance equals speed times time. Since the distance is the same, there is the same destination. This is a typical situation involving two quantities related to each other in an inversely proportional way, because any decrease in speed brings an increase in traveling time by the same factor. Thus, we have for the two situations given in the clues the following is shown on screen. We can write the last equation in proportion form using fractions, i.e. where V1 equals 60 km per hour, D1 equals 3 hours, V squared equals 20 km per hour and T2 is to be calculated. Thus, we have the following as shown on screen. Using the cross-product method described earlier, we obtain the following as shown on screen. Graph of inverse proportion. From the previous example, we have demonstrated that two quantities involved in an inverse proportion have a relation of type A times B equals constant, which we can write as the following. The graph of this relation is called hyperbola. It is a curved line that approaches the axes without touching them with the increase in the values of A and B. To increase the accuracy of an inverse proportion graph, we must use as many points as possible. Thus, if we reconsider the previous example, we can form the following table. We can write the time axis in the horizontal direction as we do in physics, while the speed values are placed in the vertical direction. The graph looks like this. The example on screen provides a closer look at the graph with the part corresponding to the small values shown. This is provided to make the values of the table more evident. Example 6. The graph of an inverse proportion is shown in the figure on screen. A. What kind of proportionality is this? B. Calculate the constancy of this proportionality. C. How many people are needed to dig the same hole in half an hour? D. How long does it take to a single worker to dig the hole? Solution 6. A. The graph shows an inverse proportion as the graph's shape is a hyperbola. B. Since we have an inverse proportionality, the relation involved has the general form as shown on screen. Where B represents the number of people needed to dig the hole, A represents the number of hours needed for this work and C is the constant of proportionality. From the graph, we see that 12 people can dig the hole in 2 hours. B equals 12, A equals 2. Other values that are clearly spotted in the graph include 8 people in 3 hours, B equals 8. A equals 3, 6 people in 4 hours, B equals 6. A equals 4, etc. If we substitute one of the sets of values in the general form of the proportion, we obtain the following. Hence, the constant of proportionality C is as shown on screen. Therefore, the inverse proportionality shown in the graph is as shown on screen. C. Knowing the formula of this inverse proportionality helps us find other values not indicated in the graph. Thus the number of people needed to dig the hole in half an hour, A, equals 0.5, is as shown on screen. If there is a single worker available, B equals 1, it takes the following shown on screen to dig up the hole.